Hi ITC, my name is Yellow Osman. On behalf of Chet Sharp, myself, Brian Yu, Kareem Sedan, and David J. Malin, I'll be presenting this talk on an open source API-based framework for assessing the correctness of code in CS50. If you would like to reach out, please feel free to do so, and if you would like access to the paper or the slides, please visit the URLs on the screen. CS50 is Harvard's largest course with over 800 students on campus. It's a one-semester amalgam of courses generally known as CS1 and CS2. CS50 previously tasked its teaching assistants with manually compiling and running code to assess its correctness. However, naturally, teaching assistants began to automate this work for themselves. This automation, though, proved unmaintainable over the years, and that's why CS50 staff considered adopting existing unit test frameworks to assess the correctness of code, such as perhaps CUnit for assignments in C and perhaps unit test for assignments in Python. However, adoption of any such framework would require tailoring assignments to that framework, and the staff was less inclined to prescribe that students break up small programs into even smaller functions solely for the sake of testing. Of interest then became a framework via which the course's staff could automate assessment of correctness of code and provide feedback that would not impose conventions of students' own code. Thus, Check50 was born. This is yet another homegrown automatic assessment tool. We realize there are many such tools out there, but we've made some key decisions in our design of Check50 that we hope resonate in the community, and we'd like to share and discuss our experience of using such a tool over the years. Check50 is a command line tool that you might choose to run like so, and if you do, you might be greeted with the following results. A green smiley face here indicates that a check is passed, whereas the red frowny face indicates that a check has failed. All the output on the screen is entirely customizable. And in fact, this was one of the design goals behind Check50, to ensure that the teacher is in full control over what is displayed to a student, such that he or she could perhaps add additional feedback or hide information to push the student to do their own debugging work instead. That string that's passed to Check50 is something we call a slug, and we use this slug to identify a Git repository living on GitHub. This Git repository ultimately hosts Check50's checks. In fact, if we go ahead and visit this Git repository now, we'll find a Python file sitting there containing checks. These are in fact the first 3 checks of which we saw results earlier. A check in Check50 is just a Python function. And all that Check50 does is expose a simple API for common tasks, such as checking whether a file exists, compiling some C code, running a program, and checking its output and the sorts. But ultimately, anything you can write in Python can serve as a check. One interesting feature of Check50 is its dependency model. Check50 allows one check to depend on the outcome of another. This allows you to prevent duplication of effort, to compile once and then use the compiled program in later checks, but also to ensure that the student is not overwhelmed by a big list of red frowny faces, but rather can focus his or her attention on just a limited set of checks that cause other problems down the line, such as perhaps in this case where, well, the code fails to compile. That's probably where the student should be focusing his or her attention now. Check50 is a Python module. It's easy to install via just one line. Pip3 install Check50, this will get you the tool. However, this makes Check50 a Python module that will ultimately perhaps run untrusted student code. And that's then why Check50 runs remote in a containerized environment on AWS by default. This is actually what happens. Once you run Check50, the student's code gets pushed over to a private repository over on GitHub. From this private repository, a webhook is fired to a CS50 server called submit.cs50.io. This server will launch a job on AWS, which will pull in the student's code, run Check50 there, and ultimately send the results back to the student. This round trip adds about 20 seconds to the execution time of Check50, but we do think the upside of a remote, safe environment, and also a place where all code is ultimately tested on the same platform, is worth the downside. To configure where this private repository lives, or to replace submit.cs50.io perhaps for your own custom solution, for perhaps concerns of privacy or for need of specialty hardware, that goes through a configuration file called the cs50.yaml. This configuration file lives alongside any sets of checks, and all it needs to do is just mark this location on GitHub as a source of Check50 checks via this one line, Check50:true. And odds are you might want to configure more than that, such as which files should be present there. This files feature is heavily inspired by Git's use of a git ignore file, in that each line either marks a globbing pattern of files as excluded or included, and each following line can overwrite that. So here we exclude star, exclude everything, then include all Python files, and then require a specific Python file to be present there. There's also the option to list any pip installable dependencies. Check50 will ensure these are installed locally if running in that mode, or remotely if running in that mode. This dependency list makes it easy to add functionality to Check50, such as you can write your own Python module, add it to this list of dependencies, and Check50 will then have that Python module available when it's running either remotely or locally. In fact, we've done so at the University of Amsterdam quite recently by adding support for Jupyter Notebooks. Simply by writing a Python module that could check notebooks, adding it to the dependency list, it would then be available for all students to use without needing an update of the tool or to wait for approval of sorts. Check50 exposes a JSON API for interfacing with any existing gradebooks or LMS systems out there. To get these JSON results, you can either run the tool yourself, query an endpoint over on submit.cs50.io, or set up a webhook. But ultimately, the task to go from these JSON results to a grade, that's left up to the teacher, because we realize there are ever so many ways to form a grade. Ever since Check50 has been employed in CS50 back in 2012, we realized some upsides of the tool and downsides. Perhaps not surprising, consistency was a good upside. No longer teaching assistants have to manually compile and run code themselves or debug code, and that's time they could now spend on writing qualitative feedback for students. But students started to perceive the assignments as more difficult. In fact, in 2012, students rated the course's assignments on 4.2 on a scale of 5, where 5 would be excellent. Whereas in 2012, just when Check50 was introduced, students rated those same assignments of 3.9. We speculated this drop was in part because students now started to perceive the assignments as more difficult, because now they had Check50 prior to submission, and students were now confronted with the fact that their implementations were perhaps not yet quite right prior to submitting code rather than after. That said, students have made plenty use of Check50. In fact, correctness scores are now higher than ever. In 2017, 90% of submissions received a perfect correctness score. But we do also see some downsides, and one of which is overusage. We realize that some students have perhaps started to use Check50 as an alias for compiling, for perhaps Clang, for C programs of sorts. And some staff members do worry that students stop developing their own habit of compiling code, running code, testing and debugging code, and started using Check50 as a one-stop shop for all. We also worry that some students started to develop a trial and error strategy where they were just trying out things in their code and then throwing it at Check50 to see if it would stick. To mitigate these concerns, we've recently begun to restrict use of Check50 at term start to ensure that all students had developed their own habit of compiling code, running code, and testing code before introducing Check50. We've also recently added support for private checks, checks that students do not see themselves, and hidden checks, checks that purposely provide little to no feedback to push a student to reproduce the test case themselves. However, we continue to see overusage and trial and error strategies employed in class. And if you do consider adopting a tool like Check50, perhaps, do consider that these two things might develop. If you would like access to the paper or the slides, please visit the URLs on screen. Check50 itself is entirely open source at github.com/cs50/check50, and if you would like to try the tool out for yourself, please head on over to the documentation at readthedocs.io. If you have any questions, suggestions, or the like, please feel free to reach out. And on behalf of Chad, myself, Brian, Kareem, and David, this was CS50.